Hello everyone, welcome to the session on microstrip antennas. Microstrip patch antennas are also often called as patch antennas or printed antennas or simply microstrip antennas. Microstrip antennas are often used where thickness and comfortability to the host surfaces are the key requirements. Now let's look into overview of microstrip lines. It was invented by Bob in 1972 and become popular early in 1970s. It is most useful antenna at microwave frequencies. It consists of metal patch on the top of the ground dielectric substrate. The patch is made up of conducting materials such as copper or gold. Since patch antennas can be directly printed on a circuit board, these are become popular in the mobile market. These are low cost, low profile, and easily fabricated antennas. Various patch antennas have square, rectangular, circular, triangle, or elliptical shapes. But rectangular and circular are the most widely employed patch antennas. Square patch antennas are used to generate a pencil beam and rectangular patch for a fan beam. For circular patches, the calculation of current distribution is relatively more complex. Now, let's start with the advantages of microstrip antennas. Microstrip antennas are lightweight, smaller size, and lesser volume. These can easily be molded to any desired shape because of the conformance structure. Their fabrication process is simple, production is easy, and fabrication cost is low, and they can be manufactured in large quantities. The fabrication process is compatible with microwave monolithic integrated circuit and photoelectronic integrated circuit technologies. These support both linear as well as circular polarization. With the microstrip antenna, it is easy to form large arrays with half wavelength or lesser spacing. Coming to the disadvantages, microstrip antennas suffer a number of disadvantages as compared to conventional antennas. These are low bandwidth, low efficient, and low gain antenna with low power handling capacity. An effort to improve their bandwidth, which is usually limited to the range of 1 to 5%, results in additional complexities. These antennas also suffer from the efforts of radiation from the fed point and junctions. These are poor end-fire radiators. Besides, the surface wave excitation is there in these antennas is an added limitation. Coming to applications, it is used in satellite communication, microwave communication, cell phone antennas, and even in GPS also. Various type of array and microstrip antennas are shown here, where feeding points also clearly mentioned. First one is linear, second one is 2x2 array, and another is 8x2, 8x8, 4x8. Different feeding arrays are shown here. Coming to the most popular rectangular patch, the design will be like this. Here, this is the patch and substrate ground plate. Length of the patch is L and width is W, and the substrate height is H. Likewise, the circular patch is also shown here. And this is the area A is taken for circular patch. Now coming to the principle of operation, the patch acts approximately as a resonant cavity, and this cavity allows only resonant frequencies, and at resonant frequency you will be getting a very strong fields. This is most important in this patch antennas. In detail, if we want to see the figure shows the basic structure of rectangular microstrip antenna. The ground plate and dielectric substrates are underneath the patch. L is the length of the patch, which causes resonance at its half wavelength frequency. Radiating edges are at the ends of the L dimension of the rectangle, which sets up the single polarization. Radiation that occurs at the ends of the W width is far less and is referred to as the cross polarization. Let's look into the side view and the distribution of E field under the patch. Due to the half wave nature of the patch, the field under the L edge are of opposite polarity and finally propagated out into the direction normal to the substrate in the same direction. In the far field perpendicular to the substrate, the radiation from the two ends added up because the field are in phase. At offshore site, the intensity drops as the field of the two edges go far and far and out of the phase. At two angles, the fields exactly cancels. Thus, the microstrip radiation intensity depends on the direction it is viewed. Here, the current distribution inside patch is shown, and the current voltage and impedance distribution along the patch resonant length is also mentioned here. For effective radiation from the microstrip antenna, the structure need to be half wavelength resonated with a thicker dielectric material of low dielectric constant under the patch, but the height still need to be fabricated of wavelength, fraction of wavelength. Now, let's move into the feeding techniques. Microstrip patch antenna can be fed in variety of ways. These feeding methods can be classified as contacting and non-contacting feeds. In contacting feeds, the RF power is fed directly to the radiating patch using a connecting element such as microstrip or copper line. Coming to non-conducting scheme, electromagnetic coupling is done to transfer the power between the feed lines, and the radiation patch feed techniques include aperture coupling and proximity coupling. Let's start with microstrip line feed. In this technique, a conducting strip is connected directly to the edge of the microstrip patch. The conducting strip is much smaller in width compared to the width of the patch. There are many versions of microstrip line feeds like center fed, off fed, inside fed, and quarter wave line fed. And the main advantage is it is easy to use with array feeding techniques, array structures. And it is very simple in construction. But coming to the disadvantages, significantly the radiation will be high in thicker substrates, and we can find deep knots or patch current, and the radiation pattern is also destroyed. Coming to the next classification, coaxial field. The coaxial field, or otherwise called as probe field, is very common technique used for feeding in microstrip lines. The inner conductor of the coaxial conductor extends through the dielectric and is shouldered to the radiating patch, while the outer conductor is connected to the ground plate. The position of feed can be altered to control the impedance. Simply, the match of impedance give you an correct transmission. This is very simple for construction, and we can directly compatible with coaxial cables. But disadvantages are radiation for thicker substrates and not easy for array of microstrip antennas. The next is aperture coupled patch. This feed technique is also called as electromagnetic coupling scheme. In this scheme, two dielectric substrates are used such that the feed line is sandwiched between the two and the radiation patch is on top of the upper substrate. The feed circuitry is shielded from the antenna by a conducting plane with a hole to transmit energy to the antenna. The coupling aperture is usually centered under the patch, leading to the lower cross polarization due to symmetry of the configuration. And because of this coupling nature, it is easy to have higher bandwidths and allows for use of different substrates to optimize antenna and feeding performances. But disadvantages is we need to go for multi-layer fabrication, which is a bit complex. The last classification, that is proximity coupling. This also comes under electromagnetic coupling feed. In this, the inside feed is trapped just before the patch antenna, or the probe feed is trimmed such that it does not extend to the patch antenna. Then the proximity coupling feed is used. The advantages of couple feed is it adds an extra degree of freedom to the design. The gap introduces a capacitance into the feed that can cancel out the inductance added by the probe feed. And again, the drawback here is multi-layer fabrication is required and exact match is also required. Because of this, it is used for lesser extent. Thank you.